Good morning, everybody. It's a pleasure and honor to be here, and thanks for the kind invitation from Mr. Minister Abdalati, Minister of Water Resources. You know what? I just need to take a deep breath and step back a little bit so that we can really know what we are talking about here and to address the extent of what we are trying to address here. When we talk about global climate change, in my opinion, I think we have to address it from a holistic point of view. We cannot only talk about climate change or water resources or impact of climate change or water resources without thinking about the system that we are living in from the interacting components or the interacting spheres, if you will. And by the term spheres, I'm referring to the atmosphere, the hydrosphere, the bio, the cryo, and as such. So the system that we are living in right now is made up of all these spheres, and there are a lot of mechanisms and interactions that happen between all of them, and we need to be aware of what's going on across all of that at a global level so that we can come down and scale the problem into our different regions and try to act at a local level. And that might be a new term that most of you might not have heard of. So we are talking about a global impact at a local scale, and this is where the term global is coming from. The recent IPCC report had triggered the attention of most of the scientific community and the world leaders about the 1.5 degrees Celsius. But let me also address why, the IPCC is coming back now and saying 1.5 scenario, or they are addressing the 1.5. I want to thank Her Excellency Minister Yasmin for the historical record that she gave us for the development of the Paris Accord and the consequences and what has been happening since then. When they said let's keep the temperature of the planet by 2 degrees Celsius by the end of the century, the IPCC was under a lot of attack, and so many people were saying, you know what, the IPCC is trying to frame the problem in a nice way and not really talking about the issues that we are facing or we are suffering. And maybe this is the only time that the IPCC is coming out in a very aggressive way, and you know what, trying to set the bar. And let's talk business now. The 2C is quite a stretch for the scientific community that was recognized a while back, and people were saying, you know what, even the 2C is way too much to think about. So that's why they are talking about the 1.5 degrees Celsius, and there is a very specific reason why they are talking about the 1.5 degrees Celsius now. I'm not going to read all these quotes, I just left them here for you to read. But the intriguing statement that all of us must be aware of is the 12-year limit. They are saying we only have 12-year limit in order to achieve the 1.5 degrees Celsius by the end of the century. And there is a very specific reason, because if we did not achieve that, we are moving in a totally different direction. We are moving in what we call the Anthropocene. Most of the people might be aware of the Holocene as one of the eras, but maybe you are not aware of the Anthropocene, which is being projected to be the next era. If this system, and by the system I mean the planet Earth, if the system hit the 1.5 threshold, there will be a lot of intrinsic feedback mechanisms which will not be reversed, which will not be stopped. In other words, once we hit the 1.5 and we keep doing business as usual, we are going to bypass that, and we are going to come into totally different scenarios that nobody is even aware of, or humans cannot even comprehend or understand. The figure that I'm showing you right now on the right hand side, it's showing you the interaction on the time scale and stability. And by the term stability, or that vertical axis here, I'm referring to the inverse of potential energy. So for physicists in the audience, if we talk about potential energy, the system which is at the very top of the curve is quite unstable. So planet Earth on the very top is very, very unstable, because with a small kick in the energy, it's going to fall down the hill. And at the bottom of that slope, like the stabilized Earth, that it is very stable because you have minimum potential energy. So it will need a lot of work, a lot of energy in order to kick the system out of that stability mode. So what we want, we are in a location where we have to make decision. The Earth is right now having two pathways. Either we go to the right-hand side and then we fall all the way down to what we call the hot house Earth. And that's the Anthropocene era where everything is going to be gone. Or we divert by the Earth stewardship and trying to do business the right way and then go back to the stabilized Earth. If we go off the record and if we reach the 1.5, these are the RPCC scenarios that they have been talking about. The RCP, the term RCP represents representative concentration pathways, and it's all linked to carbon dioxide. So I'm not going to go there. You are aware of the CO2, but let me tell you something. Right now, as we speak today, the CO2 concentration in our planet is above 400 part per million. We already achieved an increase of 1 degree Celsius. So if we keep business as usual, it is very likely that we are going to reach the second scenario, which is the RCP 4.5, reaching to 538 part per million, which means an increase by almost 3 degrees Celsius. The World Risk Report has projected that already, and you can see the direction. Most of the runs, most of the ensemble models are pointing towards that. The average of the projections is sitting towards 3 plus. And if we talk 3 degrees plus by the end of the century, we are talking billions of people losing their lives. We are talking about extreme events that people have not heard of, and I'm going to share some with you. This is one of the scenarios for the 3%, for the 3 degrees Celsius, where Alexandria is one of the 5 cities in the world which is at risk of being at very high risk, let's put it this way. Some of the temperature profiles that I ran myself, and you can see the curve, the green curve at the very top, that's 2018. All the gray curves in the middle, this is since 1800 something. So I'm showing you climate record, like more than 100 plus years of data that you can see. All the gray curves are the curves in the middle, which are showing like, the stable kind of environment. All the ones at the very low are the extreme cold events. All the ones at the top are the extreme hot events. The green curve is showing you June month was the hottest for Alexandria this year. Same for apply for Marsa Matruh, and you can see some of the areas which might be inundated. Alexandria, if we keep business as usual, this is what's going to happen in the Delta region if we have an increase by 3 degrees Celsius. Crises like this, these are the kind of extreme events that we are talking about. Since the session is about climate and the environment, so I'm going to touch bases very fast on some of the environments. Floods everywhere, forest fires, extreme cold, extreme hot anomalies, as you can see, inundation, flooding, retreat of glaciers, massive dust storms, decline in glaciers, and dust events that we have not heard of, that we did not see before. The scale of the dust events, as you can see here, is quite large, and I have a very specific reason to show dust, and I'm going to tell you why in terms of climate sensitivity in a little while. But you can see here how dust particles are advancing as a wall of debris, and you are going to see in few seconds, and that's real-time video for a massive dust event happening in Iraq. During daytime, as you can see, that was daytime, and you can see the bunker where the tent or where the people are staying, see the lights on the far left-hand side. It's getting dark. It's getting absolutely dark. So in the middle of the day, you have dusty events of that magnitude, which can change or translate your daytime into nighttime. And I have a very specific reason to show this slide, because I want you to understand that our climate system is very sensitive to mostly 2 variables. Greenhouse gases that we are all aware of. We have been talking about greenhouse gases, well-mixed greenhouse gases, methane, CO2, and as such, you name them, and aerosols. These are the major 2 drivers controlling our climate sensitivity equation. It depends on the radiative forcing of greenhouse gases and aerosols. And you can see from that curve, everything on the right-hand side is causing warming, or what we call positive forcing. Everything on the left-hand side is causing what we are calling negative forcing, or cooling down our climate. So in order to put things in perspective, aerosols are the most important, of course, with greenhouse gas, but they are one of the most important variables in understanding our climate sensitivity. Aerosols migrate very long ways. They deposit on glaciers in the Himalaya, showing retreat of glaciers. In some of the coming slides, I'm going to show you some of the research that we have been conducting ourselves, and all of this published already work. So you can see the retreat 1972, 1989, 2000 over the Himalayas. A most recent publication that appeared 2018, showing the long-range transport of dust from China across the entire Pacific, making a landfall on the Sierra Nevadas in California. And you can see the retreat of the glaciers from 2000, 2008, 2018. So you can see the advance of how the glaciers are declining. The Red Sea, the impact of dust particles on changing the algal blooms, the fertilization that happens in the Red Sea, how much coral reefs are being impacted, the change in the dynamics of the water currents. The third panel on the right hand side from the top, you can see the counterclockwise and the clockwise. These kind of cyclones are indications of upwelling and downwelling. So it's telling you a lot about the nutrition that happens, and how much impact is going to happen on fisheries or corals or marine habitats in general. Dust storms have been, believe it or not, are contributing dramatically to the formation of hurricanes. By the term hurricanes, I mean a'asir. The hurricanes which happens, they develop off the west coast of Africa and they propagate across the entire Atlantic, making a landfall on the east coast of the United States. In one of our recent publications in 2018, working with a team from JPL, Caltech, and also James Campbell, he is from the US Navy. And from this, you can see the cross section. The cross section that I'm showing you here is showing the impact of dust particles and its relationship with water. So precipitation is happening with dust. You can see here a report that came out from NOAA, from FEMA in the US, saying how much hurricanes have been causing a lot of damage in the US, and the total amount, the total lump sum here is showing more than $200 billion in losses the past year because of hurricanes. I mentioned a couple of years back that we can do vegetation in Egypt, which is going to minimize the amount of hurricanes that we can see in the US. And look at that. You can see here how much dust is leaving the west coast of Africa, propagating across the Atlantic and being washed out in the development of hurricanes. You can see right now Hurricane Irma is going to develop. And you can see the dust hitting off sea salt, of course, and smoke. The interaction of these mixing scenarios are addressing or should be addressed in our climate change. So I see Hurricane Harvey is developing. You're going to see Hurricane Irma in a little bit. But you can see the interaction between dust and water. It's very important to understand this concept, and I will tell you why in a bit. So as you can see here, the development of hurricanes and how Irma is developing and washing out all the dust and intensifying. So dust particles act as cloud condensation nuclei. They contribute to that formation. In Egypt, all of you guys are aware of the dusty event or the flooding or the heavy rain that happened, which affected Cairo dramatically. At that time, there was some simulations done in order to see what's going to happen with the water. But with interaction with the Ministry of Water Resources, we were working together, and I was telling them, you know what, actually what's going to happen the coming few days is not precipitation. You're going to get a massive dusty event first, and after that you might get the precipitation. And this is exactly what happened. And you can see here the precipitation peaks are following peaks of the dust, which happened in Cairo. And actually this paper is to appear 2019, and I'm just showing you the author proof. We just got the proof from Springer Nature. The long-range transport of dust coming across Africa, as you can see, on daily basis from Algeria, from the Sahel region, going towards Cairo. So again, dust is very, very crucial, very important. Why I'm stressing on dust? In the latest report, NASA published this image and saying this is the worst drought that has been facing North Africa and Southern Europe and Eastern Europe in the past 900 years. And you can see this is gravitational anomaly. I'm not talking satellites now. I'm not talking, electromagnetic spectrum. I'm talking gravitational anomaly. And you can see, these very dark spots here are showing you massive decline in the underground water aquifers. So the reason that I'm showing that, because with more desertification, what are you expecting? We are going to have much more dust. We are going to have a lot of dust in your atmosphere, which is going to make things even worse. So the feedback mechanisms are quite important. This is what happened in Iraq because of climate change and also because of the dams that have been built. You can see the water storage which is happening in the Furat, Digla or Furat, Euphrates and Tigris, and you can see here the decline. You are going to see a very dark red spot, which is an indicator of the decline in the water content in the underground. A lot of people might not be aware of global modeling or global phenomena. You might be hearing about PDO, Pacific Decadal Oscillation, SOI, Southern Oscillation Index, NAO, North Atlantic Oscillation, El Nino or ENSO phenomena. El Nino is a global phenomena which does have an impact, or it results as a consequence of a failure in the interaction between land, ocean, and atmosphere. So El Nino is supposed to be bringing a lot of rain to different communities. California in 1997, 1998 witnessed a massive El Nino with a lot of rain. This year, 2015, 2016, it was expected to have a lot of rain. However, this didn't happen. The El Nino was accompanied by a massive drought event in California that we were able to forecast beforehand. Coral reef habitats in Hurghada. You can see 1985. This is the picture of Hurghada, and this is 2014. Massive stress on the coral environment, massive stress on the marine environment, and the corals are having a big problem that we can talk about in a different context. This was appeared on the NASA Earth Observatory. Okay, so now we give an idea about aerosols and how the atmosphere can be playing a role. Let's now talk about a little bit about the underground. What's the situation for the water resources in the Nile Basin? So Grace, I'm showing you an experiment which is based on the gravitational anomaly, and I'm showing you two variables, something which is called the mass con and water equivalent height, where the mass con is going to be depending on the gravitational, the content. So if you have a water body, it's advancing or retreating by this kind of motion, it does attract one of the satellites at the expense of the other. So the motion of the satellites is an indicator of how the gravitational anomaly is changing, which is telling you how the underground water is moving, or if you have any kind of recharge or not. This is in Egypt. So for those who are talking about underground water all the time, and Egypt is floating on massive amount of underground water, we have to be very careful with what we are saying. These are the different mass cons for Egypt, and you can see here, I'm numbering only 4 of them, 1, 2, 3, 4, and you can see the water equivalent height. It's on the decline. This is coming from JPL, from NASA. This data, it's Grace data, everybody can have access to it, everybody can process it. So this is not something secret here. So you can see the decline in the underground. You can see this big drop that I'm showing with the red circle. So we have to be very careful with the water sources. The fact that I heard some news sometime that it is rechargeable aquifers. We don't have that much rain in order to talk about rechargeable. In Sudan, you can see some of the mass cons are also declining, others are increasing, which is expected. You have rain in some places in Sudan, so you might be expecting that. In Ethiopia, even in Ethiopia, they have a lot of rain, but evaporation, nobody's talking about that much. You can see mass con number 2 is also underwater stress, and the fact that you see this kind of drop, it's quite alarming. So even with some scenarios of climate change, even the countries which are receiving a lot of rain, they should not be counting on that. And let me tell you why. What I'm going to show you over the coming few slides are climatology work over the course of few decades. And this is representation of the month of December. So I'm just going to show you the month of December for precipitation. You can see the red anomaly means total decline in precipitation, and this is TRIM composite climatology. TRIM is a tropical reformation emission, works in the microwave region of the spectrum. You can see December, a red spill here, you don't have that much rain. In December, again, focusing only on the Nile Basin, you can see the signal, across the Nile Basin, mostly in the red zone, in the cyanish blue, which is not that much rain, and I'm talking December. Evapotranspiration, nobody's talking about that a lot, and we have ways of quantifying evapotranspiration across the Nile Basin, and you can see the signal in terms of vegetation and vegetation enhancement. Soil moisture, one of the most important parameters when it comes to climate change, or when it comes to understanding vegetation patterns or irrigation or things of that sort. Soil moisture, NDVI, vegetation healthiness, vegetation index, showing you also those gray colors are quite alarming because the healthiness of the vegetation is not that good, and we can show the monthly climatology, and Grace showing you the underground water. So across the spectrum you can see there are a lot of drops in most of these variables. So we have some issues. And again, I'm going to take from Her Excellency words, whenever there are challenges, there are opportunities. So is it so dark? It is not, but it is alarming. And we should not take it lightly, and we should have some actions. And how we can move forward, how we can increase. If we want to talk about replenishing our underground water aquifers, how we can move forward. A most recent article that appeared in Science few days back is talking about the modeling of having the Western Desert overlaid by solar panels. When you have massive amount of wind and solar energy production, it will change the local climate of the Western Desert. It will enhance a lot of rain, and it will decrease your temperature anomaly. The first few years, it might give it a little bit of a kick because of advection, so you might see and observe an increase. But if you have the Western Desert across the globe, like, producing electricity, this is not a project for Egypt, this is a project for the world. And this is where like you can be really closing the gaps between users and providers, because you are going to be providing energy and Egypt, by the way, is a leader. Egypt does have the biggest solar farm worldwide, which has been even acknowledged by a lot of policymakers in the US. Earth Observations for Energy, ESA, is working in this direction. They are trying to find the linkages between the energy sector and the space program, the space sector, between energy and space, how we can identify the most promising energy subsectors for space exploitation, how we can identify potential sites for solar and wind power generation. These are ongoing projects. These are visions which are already existing, and we can capitalize on that. From that, we built on this, and we were very lucky to have one of our projects through which we created the Solar Atlas of Egypt, and that was delivered to the Ministry of Electricity past year. And if all of you, I invite all of you to visit the website, the official website of the Ministry of Electricity and Renewable Energy, and you are going to see the Solar Atlas of Egypt is already available to the public, where we took care of the scattering happening with the dust. So we quantified the amount of dust. You see how much attenuation is happening at the different spectral regions, in the UV, visible, and the infrared. And this is the momentum of the project, where you can identify any single spot in the country where you can identify how much solar power can be harnessed, either for the PV projects or for the CSP. And these are parts from the Solar Atlas, which is available online, as I mentioned. So you're going to see all the lands which have been allocated by a presidential decree, and we are calculating for them, the CSP and the PVs, how much energy. So basically they have the energy portfolio in order to develop projects. For the water resources, I will invite you to come to attend the session TS32 about precision agriculture, where we are going to talk about technologies where it can really address the demand and how we can reduce the amount of the water that we are using in our water resources. So we are going to have a session today. We are going to have some very interesting talks. I invite you, please, to show up. And my key messages, I want to conclude by one slide, which is going to give you the key messages. Civilization is at a stake. We have to realize that right now we are at a position where we need to take the right decision. There is no more time available for any of us. Global warming to 1.5 is likely to happen between 2030 and 2052. That's where the 12 years message is coming from. At 1.5 warming, majority of coral reefs would die out. We will not have coral reefs anymore globally. I'm not talking about Egypt only. Globally, like if people are aware of the barrier in Australia, it is a sad situation there. The interplay between droughts and flooding, like with the El Nino or global phenomena, you are going to observe some flooding and some droughts. And that interplay between these kind of two extreme events will make the world food supply very less secure. So that's going to be quite problematic. It is not a binary problem, like it is not like a red or blue. It is just doesn't kick off and in full force and at any particular temperature level. No, climate change is a function which is based on time. Once you keep using greenhouse gases, it's going to keep on rising, and it's going to get worse. Today, average price, and let me tell you also this is very important for future investment, so that we have to be aware of that. Right now, the carbon tax or the carbon price per ton is $8 for across the globe, $8 per carbon ton. In the future, it is anticipated, based on these discussions, that there is a current proposal right now for the carbon tax to be $5,000 per ton. You can see the jump from $8 to $5,000. And by 2100, they are estimating it to be $27,000 per ton. So $5,000. So investments in this direction might be quite crucial. My recommendations: Egypt can be an advocate for serious considerations of climate change and impacts at a global level, leading global effort for high-resolution mapping of dust. We don't know where the dust is coming from pockets. We just know it's coming from Sahara, but in order to be able to reclaim, or in order to be able to have like intense vegetation, you need to highlight those kind of pockets, which is very, very important. High need for increasing the green cover. The project in Egypt, about the 1.5 million fadans, is a visionary project. I totally support that. It's one of the highly needed things, but even 1.5 is not good enough in my opinion. We need to go beyond that. But where are we going to get the water? That's the problem. We have to think about, and we have to be creative. We have to make use of our current water resources before thinking about others. And I'm going to leave you with some meat for thought. So thank you so much for your time. And thanks, Mr. Chairman, for allowing me to finish my talk. Thank you so much.